Hi students, all of you welcome. Welcome to Sunil Engineering Academy. I am Sunil Kumar Bandaro. Students, from today onwards, we are going to discuss general science, physics, useful for all your competitive examinations. A small introduction about myself. I have 7 years of teaching experience in online platform and I have cleared many of written examinations and nearly 200 selections in RRB examinations through my YouTube channel. Students, first of all, we are going to start with the physics. In the physics, each and every topic we will discuss. After that, we will take topic wise MCQs also. You have to do a small thing, that is you have to attend each and every session. And also please share the information to all your friends. So first of all, I am starting with the topic in the physics is electricity. After electricity, we will take magnets and magnetism. Okay, electricity, very important topic, guys. You can expect maximum questions in this topic. Okay, so first of all, in the electricity, the fundamental quantity is charge. Charge is denoted with the letter Q. What is this charge? Charge is nothing but which experiences electrical forces. Charge is nothing but which experiences electrical forces. Those forces may be attractive forces or repulsive forces. Any type of force which experiences electrical forces is nothing but, you can say, charge, denoted with the letter Q. Okay. So which experiences electrical forces is nothing but, you can say, charge. Charge is denoted with the letter Q. Okay, and the units of charge, very important. Units are very important. Okay, units are coulomb. Okay, why we have given the units as coulomb? Because Coulomb is a scientist given two important laws on these static charges. Okay, so those are also very important. Coulomb's first law, Coulomb's second law. Now we are going to discuss those. What is the Coulomb's first law? Coulomb's laws. Coulomb first law. This Coulomb first law will give the idea, that is the nature of force exists. So just now I said there may be attractive force or repulsive force. Here first law will give the idea which type of force, attractive force or repulsive force. So it will give the idea nature of force exists between static charges. Okay, so that means he has given statement like charges repel, unlike charges attract. Okay, so like charges repel, unlike charges attract means if we have both are a positive charge, there is a repulsive force is exist. If unlike charges, one is a plus, one is a minus, or one is a minus, one is a plus, then attractive force is exist. Okay, that is given in the Coulomb's first law. So Coulomb's first law will give the idea nature of force exists. Like charges repel, unlike charges attract. And what about the Coulomb's second law? Second law will give the amount of force exists. Here in the first law, just they said nature of force, but they have not given how much force is exist. In the second law, they will give how much force exists. So Coulomb's second law. It will give the idea of magnitude of force exists between the two static charges. Magnitude of, very important question. Magnitude of force exists between two static charges. Static charges. Okay, so that magnitude is nothing but, for example, if you displace two charges, let us take charge q1, another charge q2. So there is a opposite charges, means there is a attractive force, and those are displaced with a distance d. Okay, then that force is proportional to product of two charges, and inversely proportional to distance square. Very important. So second law will give the magnitude of force exist between two static charges, that is proportional to q1 q2 by d square. Okay, so if you remove the proportionality constant, we have to take one constant, that is k q1 q2 by d square. Here k is nothing but 1 by 4 pi epsilon. What is this epsilon? Epsilon is nothing but permittivity, which permits the charge through it. Okay, so this epsilon is again divided as epsilon naught into epsilon r. This epsilon r is equal to 1 for air. That means if you displace within the air, epsilon r is equal to 1, and epsilon naught is a fixed value, very important, 8.85 into 10 power minus 12 farad per meter. Units of permittivity, farad per meter. Note down that point, very important. Okay, so if you substitute all these values, then the k value you will get, 9 into 10 power 9. Okay, so if you substitute pi value and epsilon is equal to epsilon naught into epsilon r is equal to 1, and epsilon naught is equal to this value. If you substitute all this, k is equal to 9 into 10 power 9. So you have to directly remember force is equal to 9 into 10 power 9 q1 q2 by d square. Very important. So based on this formula, there is a chance of getting one numerical question. Okay, so they will give charge q1 q2 and distance. Okay, so you have to find out the force. So second law will give the magnitude of force exist between the two static charges. So note down this one, and the units of force you know very well, newtons. Okay, after this charge, we are going to discuss the very important quantity in the electricity, that is electric current. Okay, so let us take electric current, or simply you can say current. Okay, so current is denoted with the letter I. What is this current? Current is nothing but flow of electrons. Flow of electrons is nothing but, we can say, current. For example, if the water is moving or water is flowing, that is a water current. In the same way, if the electrons are moving, then you can say that is the electric current. So that means you can say the current is nothing but a moving particles. Whenever there is a particles are moving, that movement is nothing but, you can say, current. Water is moving, water current, electrons moving, electric current, like that. Okay, so current is nothing but flow of electrons. Flow of electrons is nothing but, you can say, current. And we can also define this current is nothing but rate. Rate means time, rate of flow of charge. So we can also define the current as rate of flow of charge, that is the charge flowing, the amount of charge flowing flowing in a particular time is nothing but we can say current. Okay, the amount of charge flowing in a particular time is nothing but we can say current. And the units of current, very important, units are amp or amperes. Okay, amp or amperes. Okay, so here 1 amp is equal to dash. That is a very important question. If the current is in amps, charge q is in coulombs, time t is in seconds. So from this, I is equal to q by t. The current is in amps, charge is in coulombs, time is in seconds. From this one, we can note down 1 amp is equal to 1 coulomb per 1 second. Very important question. 1 amp is equal to 1 coulomb per 1 second. Okay, so that means here whenever they have given one numerical on this current based question, you have to substitute the charge always in the coulombs, time always in the seconds, not in minutes. Okay, if they have given in the minutes, you have to convert it into a second. That is a very important thing. Okay, so we will discuss question on the numericals, that is topic wise MCQs. Don't worry. Okay, and one more thing here, this current units are amperes. This current is measured by a device. This current is measured by device called, with the units name only, device is called ammeter. Very important. The device is called as ammeter. Okay. Note on this point, the current is measured by device is called as ammeter. This ammeter is always connected in series to the circuit. Okay, ammeter always, this is also very important. Whatever the point I have given, that is very important for exams. Connected in series to the circuit. Very important. Or series to the circuit or series to the load. Circuit or load. Okay, and one more important point, this ammeter internal resistance RINT means internal resistance of ammeter is 0. Okay, so if it is ideal, internal resistance of ideal ammeter, note it as ideal. Ideal means perfect. Okay, all these points are very important. Note down. So now this resistance, whenever the current is flowing, always there is one opposing quantity is there. That opposing quantity is nothing but you can say resistance. So that means resistance always opposes the flow of current. Always opposes the flow of current. So let us take that resistance topic. Very important topic. Resistance is a very important topic. Resistance is denoted with the letter R. Is denoted with the letter R. So that means which opposes the flow of current. Which opposes the flow of current is nothing but resistance. The symbol of resistance, this is the symbol of resistance. Okay, and units are ohms. Units are ohms, and this is the ohm symbol. Ohm symbol, which opposes the flow of current. That means whenever the resistance is high, more opposition, less current. So always this resistance is inversely proportional with current, or current is inversely proportional with resistance. So you can say the current is always inversely proportional with the resistance. Higher the resistance, lesser the current. Why? Because more opposition, so less current is flowing. For example, we can understand whenever the road is very smooth road, okay, there is a very smooth road, then vehicles can move faster. That means their current will be higher. Whenever the road is so many obstacles, okay, so then that means more resistance, you can say the vehicles are moving slowly. So here also same thing, okay. So resistance which opposes the flow of current, and this resistance is directly proportional to length of the wire. L is the length of wire and inversely proportional to area of wire. If you remove the proportionality constant, R is equal to rho L by A. Very important formula. Very important formula. Note on this formula. Rho is called as specific resistance. Specific resistance are also called as resistivity. We will discuss about this later, don't worry. And the units of this specific resistance is ohm meter. Ohm meter. Okay. So R is equal to rho L by A. So that means resistance is directly proportional to length. More length of the wire, more resistance. Here inversely proportional to area. So if the area is more, resistance is less. So in the road case also, road area is more, then resistance is less. Now vehicles can move easily. Okay, so same like here also. So more the area is more, resistance is less. Okay, so that means if you take this much of size of the area of the wire, then the current is easily flowing, so resistance is less. Okay, and one more thing, in case of conductors, the conductors are nothing but which allows the electricity through them. So these conductors, as temperature increases, resistance also increases, directly proportional, because of the conductors are positive temperature coefficient of resistance. Coefficient of resistance. In case of insulators or semiconductors, here reverse, as temperature increases, resistance is decreases because they have negative temperature coefficient of resistance. Okay, so that means resistance also depends upon the temperature. As temperature increases, resistance increases in the conductor. In semiconductor, resistance is decreases. These 2 points are also very important. Okay, note on all this. And if you can consider the resistance at T degree centigrade is equal to resistance at 0 degree centigrade into 1 plus alpha T. This alpha is nothing but, just now I said na, coefficient of temperature coefficient of resistance. For example, if it is a positive, then what will happen? 1 plus something means more. Okay, 1 plus something means resistance is more. For example, let us take R at 0 degree centigrade is 100 ohms. Okay, so if the alpha is equal to plus 0.001, okay, so if they are asking the temperature is increases to 100 degrees centigrade, then what is the resistance? If they are asking the question like this, now the answer is resistance at 100 degrees centigrade is equal to resistance at 0 degree centigrade. 100 into 1 plus alpha is 0.001 into temperature is the 100. Okay, so that is 100 into 1 plus 0.1. Okay, that is nothing but 1.1 into 100, 110. So that means whenever the alpha is a positive value, you are getting that as temperature increases from 0 to 100, the resistance also increases from 100 ohms to 110 ohms. Okay, so that means you can get idea as temperature increases, the resistance increases in the conductors. Okay, if the alpha is negative, here minus, then here minus. So you will get 1 minus 0.1, that is 0.9, that is 90. Okay, so in the semiconductors, this alpha is negative. So note down, alpha is positive for conductors, alpha is negative for semiconductors. Okay, so this formula also very important for numericals. Note down this formula. Okay, all of you clear up to this? Now we are going to discuss the another topic, resistivity or specific resistance. Resistivity or specific resistance. Or two names are very important. So remember, specific resistance denoted with the letter rho. This is called as rho. Okay. So here what is this resistivity? It is the property of material. It is nothing but it is the property of material. For example, if you take any one material like silver, copper, gold, aluminum, whatever it may be, each material having their fixed amount of resistivity. Each material having the fixed amount of resistivity. Okay, so it may not changes with respect to physical quantities. That means whenever the area increases, length increases, volume increases, or maybe decreases also, there is no change in the resistivity. That means it depends on nature of material, that is type of material, but not with length area. Okay, so note on that point. It depends on, very important point, it depends on nature of material, that is nothing but type of material used, of material, and also maybe temperature. So temperature. Okay, very important. It not depends on, or it does not depends on physical quantities. Physical quantities like length, area, volume, like that. Okay, that means if length or area or volume increases or decreases, whatever it may be, resistivity is a constant for given material. Okay, for given material. For example, if you can consider a silver, it is a fixed value 1.58 into 10 power minus 8 ohm meter. So for example, if you can consider copper, that is 1.67 into 10 power minus 8 ohm meter. So silver having lowest resistivity. Silver is the lowest resistivity among all the metals. Lowest resistivity element is silver. Okay, and the units are ohm meter. Ohm meter, very important. Units are ohm meter. Now coming to the conductivity. Coming to the conductivity. So conductivity is nothing but opposite of resistivity. Conductivity is denoted with the letter sigma. sigma. Okay, it is nothing but reciprocal of resistivity. Reciprocal of resistivity. Okay, so conductivity sigma is equal to reciprocal of resistivity. Then units are 1 by rho units are ohm meter. So 1 by ohm meter. 1 by ohm is nothing but you can say mho per meter. Mho per meter. Okay. So conductivity is nothing but reciprocal of resistivity. The units are mho per meter. It is also very important, guys. Very important. Note down. Generally, metals having the conductivity in the order of metal conductivity in the order of 10 power 7 mho per meter. Very important. Note down. Very important. So we have discussed resistance and resistivity and also conductivity. So we have only one pending, that is conductance. So note down the conductance. Conductance is denoted with the letter G. G is nothing but reciprocal of resistance. Reciprocal of resistance. The units will be 1 by ohm, that is nothing but can say mho. The symbol is like this. Or another unit, that is Siemens. Very important. Units are very important. Conductance G is equal to 1 by resistance, that is mho or Siemens. Okay. So once again I am going to summarize all these four properties. Resistance, units are ohms, and resistivity. With that property we have the resistivity. The symbol is rho. The units are ohm meter. Okay. In the same way, conductance. Conductance R is equal to 1 by G is equal to 1 by R. Conductance denoted with the letter G, that is equal to 1 by R, that is 1 by ohm, that is mho or Siemens. Okay, mho or Siemens. These two are inversely proportional. And resistivity opposite, conductivity. Conductivity sigma, that is equal to 1 by rho. Units are 1 by ohm meter, that is mho per meter. Or in the place of mho, you can take Siemens per meter. Okay. In the next session, we will discuss another quantity, that is potential or potential difference. So once again, revise. What is the charge? Which experiences electrical forces. Okay. The charges may be positive or negative. So Coulomb's has given two important laws. First law, like charges repel, unlike charges attract. Second law, magnitude of force. F is proportional to Q1 by Q1 Q2 by D square. Current is Q by T. Very important. Note down this formula. 1 ampere is equal to 1 coulomb per 1 second. Current is measured by the device is called as ammeter. Ammeter is always connected in series to the circuit. Ammeter is denoted with a letter like this. Okay. So ammeter is always connected in series to the circuit, and internal resistance of ideal ammeter is 0. And resistance which opposes the flow of current, R is equal to rho L by A. And in conductors, directly proportional. In semiconductors, inversely proportional with the temperature. So, and this is the formula of the resistance at T degree centigrade. Resistivity depends only on nature of material or type of material and also temperature. Okay. So if you take one silver, that is a 1 meter length, same value. 10 meter length, same value. 1000 meter length, same value only. Okay. lowest resistivity element silver. Conductivity sigma, that is equal to 1 by resistivity. Okay, so lowest resistivity is the silver, means here reciprocal, that means highest conductivity material also silver. So silver is highest conductivity. Conductivity. So this is in the order like, first of all silver, Ag, and then copper, and then gold, and then aluminum, like that. So silver is the highest conductivity. Okay, in the same way here also reverse you can say silver is the lowest resistivity, after that copper, after that gold, after that aluminum. Okay, so note down this one also, and these are the 4 important units of this. Okay. Okay, students, we will discuss the remaining in the next session, and all of you please click on like option, and also please share to your friends and encourage me to take more sessions. Thank you so much, guys.